Okay, so let's have a look at the 2023 Higher Level Maths Leaving Cert Paper 1, question 6. So the first question, let's see, part A here, we have f and g are two functions of x, which is real. F of x is x plus 4, that's linear, and g of x is a quadratic x squared minus 2. Find the two values of x for which these two functions are equal. Okay, so this is reasonably straightforward. We've just got to take our x squared minus 2, and that should be equal to x plus 4. This is just a quadratic trinomial, so we got x squared minus x minus 6 equal to 0. Factorize these. That'll give us x, and 6 is going to be 3 times 2, plus times minus, so this one is going to be minus, this is plus. So that'll give me x is equal to 3 or minus 2. So that one was reasonably straightforward. I think that's all we had to do, find the two values of x. Okay, second one now, I think this one is a bit longer. Find the area of the shaded region in the diagram below, which is not to scale, the region between the graph of f of x, which is x plus 4, and g of x, x squared minus 2, from x equal to minus 1 to 2. Okay, so let me see. There are going to be two ways of doing this. There's going to be a long, detailed way of doing it, and then a short way. I'm going to do it both ways. So look, if you are happy enough with this one, just skip on to the next question, or if you did it the short way and you're happy enough with that, that's okay. The long way is going to be taking the integral of the quadratic, just finding this area here, in other words, and then finding this area here and adding the two together. So I'll do it that way first and see how that works out. We have f of x, which is x plus 4, and we have g of x, which is x squared minus 2. So what I'm going to do is integrate x squared minus 2 first between minus 1 and this point here. So that's, just do that in a different color there, it's this one here. So I've got to work out what this value here is. So in other words, I want to find out the roots of my quadratic first. So it should be fairly straightforward. The quadratic here is x squared minus 2, so we want x squared minus 2 to be equal to 0. So that gives me x squared is equal to 2, or x is equal to plus or minus the square root of 2. So this value here, this root here is minus root 2, and this value here is plus root 2. So what I'm going to do is I'm going to integrate the quadratic first. So I'm going to take the quadratic and I'm going to integrate it between minus 1 and root 2. So that will be x squared minus 2, and we were integrating with respect to x. Okay, so if I do that, I'll get, let's see, I'll get x cubed over 3 minus 2x, and that's between minus 1 and root 2. So I'll just come down here. That'll give me, let's see, root 2 cubed on the top here. If I put root 2 in there, that'll give me 2 root 2. If I cube root 2, I'll get 2 root 2 over 3. Then I've got to subtract 2 times root 2. Now I've got to put in minus 1. So I've got minus 1 cubed here. That'll be minus 1 over 3. And then I've got to put in a minus 1 here. That'll give me plus 2. So if we keep going, let's see, we get 2 root 2 over 3, minus 2 root 2, plus a third, and then minus 2. If we calculate all of this, I'll just stick that all into my calculator. What we get is minus 5 plus 4 root 2 over 3. Now, because we've integrated below the x-axis here, we're going to get a negative. We're going to get a negative value. You can't have a negative area, so the area is actually plus. In other words, plus 5 plus 4 root 2 over 3. So what I've done is I found this area here. Found this area down here. Next thing I'm going to do is find this area up here. Now the problem with this is that we've got this little area here that we are not interested in. So what I've got to do is integrate the straight line here, the linear function, between -1 and 2, and then subtract the integral of the quadratic function between √2 and 2. So it's kind of a long-winded way of doing it, and as I say, there is an easier way of doing it, but let's just run through this just in case some of you did do this method in the exam. So let's see. Okay, so the next thing I'm going to do now is integrate the linear function. So let's do that then. So the linear function is x plus 4. I'm going to integrate that between -1 and 2. That's with respect to x. And then I've got to subtract this little white region here underneath that curve. Because remember, this line is going all the way down here to 2. So there's a little white region, non-shaded region down here. I'm going to subtract that. So that goes from √2 to 2. So that goes from √2 up to 2. And that's underneath the quadratic function, which is x squared minus 2. So let's do all of this. Let's see, I've got x squared over 2 plus 4x. That's from -1 to 2. And then over here I've got x cubed over 3 minus 2x. And that's from √2 to 2. So now I'm going to come down along here. First thing I'm going to do is put 2 in here and here. So 2 2s are 4. 4 divided by 2, 2. Put 2 in here. 2 4s, 8. Now I've got to put -1 in. Well, -1 squared is 1. And then we have -1 times 4, which is -4. Okay, so that's all of this done. Now let's do this bit here. Remember, I'm subtracting all of this, so I'm just going to put this in a big bracket here. Put 2 in here first. 2 2s, 4, 2 4s, 8, so I get 8 over 3. Let's see, I've got minus 2 2s are 4, so that's -4. So that's the first part. Then I've got to subtract, put √2 in here. So √2 cubed is going to be 2√2 over 3. And then I've got to put √2 in here, so it's just going to be -2√2. Okay, so let's do all of this. I've got 10 here, and then I've got to subtract a half, that's 9.5, and then add 4, that's 13.5. Okay, let's do all of this then. So I've got well, let me just leave that there. I've got 8 1/3 minus 4. I'll just quickly do this on my calculator, and what I'll actually end up with is -4 plus 4√2 over 3. Now, when I do all of that then on my calculator, just give me a second to do that. Okay, so I got 89 minus 8√2 over 6. Okay, so what have we just done? What we've done is we found this area up here. We found this area up here, the shaded region above the x-axis. Okay, so what I need to do now is add this here to this here, and that should give me my total area. So the total area then, total shaded region, is equal to the 89 minus 8√2 over 6 plus that bit up there that's off screen. It's 5 plus 4√2 over 3, and when you do all of that you actually get 33 over 2. So that's units squared. I don't think they gave us any units there. No, so I'm just going to say unit squared. Okay, so look, that's kind of the long-winded way of doing it. Some of you may have done it a quicker way, so I'll just run through that. So what you can do here is just subtract the two functions. So this is the alternative way, this is the quicker way of doing it if you like. So what you would do is integrate between -1 and 2, the function x plus 4, that's a linear function, which is the one furthest north if you like, minus quadratic, which is below it, x squared minus 2, and we're integrating all of that with respect to x. So you're subtracting the two functions here and integrating between -1 and 2. So if you do that, then let's see what we get. It's really the integral from -1 to 2 of, let's see, minus x squared. I'll put that one first, then I'll put the x, so it's plus x. And then we have a plus 4 plus 2, which is plus 6. We're integrating that with respect to x. So if you do that, then let's see, we've got minus x cubed over 3 plus x squared over 2 plus 6x between -1 and 2. Okay, I'm running out of room here, so I'm just going to do it up along here. So let's see, we've got to put in 2 first. So it's going to be, let's see, -2, so it's going to be minus here, and then it's going to be 2 cubed, which is 8 over 3, plus 2 2s are 4 over 2, which is just 2. And then we've got 2 6 is 12. So that's substituting 2 in here. So now let's substitute the -1 in. So we got minus, and then -1 cubed is going to be -1 over 3. Plus we got -1 squared, which is 1. So that's going to be 1 over 2. And then we've got -1 times 6, that's just going to be -6. Okay, so let's see what we get if we do all of this. We get -8 over 3 plus 14. Let's see, we've got a minus here, which is plus, and then this minus is minus, so that's -1/3 minus 1/2 plus 6. Okay, now again, let me just do all of that on my calculator. So when I do that on my calculator, I get 33 over 2 units squared. So this is maybe the way you did it in the exam. It's the shorter way of doing it anyway. Less likely to make a mistake here. Okay, so let's move on to the next part of the question. So this is, let's see, b is an element of or. It's a positive constant, and the integral from 0 to b of b e to the power bx dx equal to e, work out the value of b here. Okay, so let's do that. So we have the integral from 0 to b of b e to the power of bx dx is equal to e. So that's going to mean then that, let's see, let's do the integral. Well, if you integrate e to the power of bx, if you integrate e to the power of bx, you'll get e to the power of bx, and then you've got to divide by b as well, because if you differentiate this, you'll get b e to the power of bx, so you'll end up with an extra b. To get rid of that extra b, you've got to divide by b. But we already have a b here, so in other words, when we integrate b e to the power of bx, what we're really going to end up with is just e to the power of bx. This is because if you work backwards, if you differentiate e to the power of bx, you will get e to the power of bx times b, and that's what we have here, so that's fine. Now we're integrating between 0 and b, and that's going to be equal to e. So let's just stick in our limits then. We've got e to the power of b times b, which is b squared, minus e to the power of b times 0 here, and that's equal to e. That will give us e to the power of b squared minus e to the power of 0 is just 1, and that's equal to e. Okay, so we've got to work out what b is, so let's do that. We've got e to the power of b squared is equal to 1 plus e. Next thing I'm going to do is just take the log of both sides. So if I take the log of the left hand side, I'll get log of e to the power of b squared is equal to the log of 1 plus e. I can take this and bring it down here. So that gives me b squared log e is equal to log 1 plus e. And log e to the base e is just 1, so we get b squared is equal to log of 1 plus e. Now we have b squared there, so we want b, so b is going to be equal to plus or minus the square root of log 1 plus e, and that's our answer. However, if you come back up here, it says b is a positive constant, so our answer then, our actual answer, is b is equal to the square root of log of 1 plus e. And that's it. That's actually it for this question.